Okay, so my first goal is I would like to understand what are your goals and what would you hope to get out of these sessions?
My goal is just getting a job, yeah, in tech because I see the future in the tech that it will develop really fast. So I just want to have a foot in it.
Okay. Um, and you're an absolute beginner, right? You're like fresh in this.
Yes, it can be said so. Yeah, I
Okay.
just learned something like print or for loop or while loop or something similar just to I
Okay. Okay. So yeah, getting a job in tech is difficult. It's not easy, and it's gonna require commitment from you. You're going to have to like take the time and energy to pursue the craft,
okay.
right? It's not gonna
Mm,
happen overnight. Just so you know.
yeah.
Okay. All right, without further ado, let's begin. I'm going to send you something on Zoom chat and I'd like you to open it.
Okay.
Okay, just once open it in your favorite web browser and if you could share your screen with me. Oh, be sure to close anything that might be sensitive before you share your screen.
Okay, that wait for me.
Hmm.
Screen. You see it?
It's loading. Perfect, I see it. Okay. Okay, I would like you to think of two big numbers and then I would like you to add them.
Like 9 and 8.
Perfect. Now we need a second number.
99, yeah.
Okay, now let's add them.
Add them like plus, yeah.
Yes. Perfect. Okay, at the top right, there's a run button. Could you click that? Very good. Okay, what does it say?
We have a white space protecting it from it open. Oh, okay.
Okay, very good. It's your using a it's just like using a calculator, right?
Right.
Which is unsurprising because a calculator is a computer.
Okay.
Can we add a third number in here?
Oh, yes.
Very
Okay.
good. Okay. Can we change one of the plus signs to a minus?
Cross sign.
Oh no, keep one a plus. So one plus one minus. Yeah, perfect. Oh, what's happening?
Simple awareness of reason. Okay. So they mean like this. Okay. Okay.
Very
Yes.
good. Okay, so are you familiar with BMAS or PAMDAS in mathematics?
POMDOS. I don't know, man.
Okay.
I don't know that.
No, no, it's okay. So in mathematics, there's a convention. For example, we should multiply before we add.
Yes. I know that. I
Okay,
know that.
that does not exist here.
Like this.
Yeah.
Oh, would you say it at the same grouping level?
Mm-hmm.
Minis?
Yes.
Okay.
Notice how we have to add the parentheses.
All right.
Yes. So there is no convention. The language does not know whether or not to multiply or add first. So you
O-
must tell it. You must say, I want to multiply first. And you do that by surrounding it in parentheses. Okay.
Okay.
So
And
the conventional order of operations in mathematics does not exist here.
okay.
We have to be specific. We need to be clear by adding parentheses on our own.
Okay.
Not all programming languages are like this. Some programming languages, there are conventions. But
Okay.
here's the thing. Unlike mathematics, in programming, there are many operators. Many operators.
Okay.
And if you want to memorize all the conventions for them, it's gonna be very painful.
Oh.
This language is designed for beginners, and we don't want beginners to feel a lot of pain. So, there are no conventions. You have to be clear about what operations you want to happen first. Okay?
Okay.
All right. Now, let's try something different. Could you delete everything?
Okay.
And I'd like you to write two numbers separated by a comma.
Common.
A comma.
A comma.
That's
Uh.
the key to the left of the
Oh.
dot.
Oh. I understand.
Yes, that one. And let's surround it in parentheses.
What?
Parentheses, that's the round bracket.
Direct line ground.
Oh, no. Shift 9.
Seat nine.
Yeah,
Oh.
parentheses.
Oh.
Yeah, that one. And then closing parentheses as well. And oh, not yet. Before the first parentheses, I'd like you to write NUM.
M.
No, N for uh, what's the start?
I
What's a
don't.
word that starts with N? Oh, okay, I'm brain farting so hard right now. N for nighttime. N for night.
N for
No. N, sorry, NUM. So like N is correct. NUM
NUM
dash
dash
dash. So hyphen.
uh dash
Oh
I
no, that's the symbol to the left of the equal sign. The key to the left of equal.
equal sign. Oh, you mean this?
Yes, and then MIN.
M min.
Yes, and no space. So nummin is one word. No space
U.
between the dash.
Okay.
Very good. All right, let's run it.
Oh,
Okay, so what do you think is this doing?
I think yes. Somehow minus or something.
Okay, can we
Oh, yeah.
change the numbers?
Yeah.
Okay, I'd like you to keep changing the numbers until you have an understanding of what this is doing.
Oh, I think yes. Choosing the smaller number.
The smaller number, yes. So at
Yes.
min for minimum.
Oh, oh, okay.
So num for number. So it's saying the minimum number.
Okay.
Yes.
But
Oh,
can min stand alone? Like,
no. You can try. Actually, maybe it will work. Maybe.
oh,
Yeah. So it
oh,
doesn't understand it.
oh, okay.
Yeah. Okay. So unlike just now, we were using plus and minus and times, but now we use words, right?
Okay.
Because in program I mean, just in mathematics, there are so many math operations. We can't use symbols for all of them. We're going to run out. So we use words, num min. To,
Okay.
so we can use words for operations as well. Okay. Um, can we add this whole thing to another number?
As this whole thing,
Yeah.
like
No,
completely.
no, don't delete it. Keep it.
Okay.
And let's add the whole thing without deleting anything to another number. Yes, perfect. Let's run it.
Okay.
Yeah. So the same way we can minus and plus, we can also use plus with nummin. We can mix
Oh,
word operations with regular math operations together,
okay.
right? Now, could you move the plus 9967? Can we move that inside the parentheses?
You mean yes?
Yes, but not comma. Let's use plus. So plus 9967.
Okay. Plus.
Yes. Oh,
Uh,
space. We need space around the plus sign.
oh, oh, okay. That's good.
Oh, nice number. 10,000. Yes. So we can put the plus anywhere, right?
Yes.
Okay. So
Oh,
far, so good. So far, we have been exploring the laws of arithmetic with numbers. But let's move forward in time a little bit and let's explore algebra. Can we
okay.
delete everything?
What?
Okay.
Delete. Okay, delete.
Yeah,
Sorry.
delete. Yeah. And can you write x equals 1?
Okay.
And on a new line, s. Okay. Before we run
One.
it, what do you
Uh,
think will happen?
Nothing else will print as. Yeah.
Print s.
One.
1. You'll print 1? Okay.
Yeah.
So variable substitution, right? When we
Yeah.
see s, we see 1.
Okay.
Okay. Now, can you change that to s plus 1?
S plus one.
Yes. Oh, white space.
Oh, my bad.
That's all good. Happens.
Uh,
2.
Okay. Yes.
Very good. Okay. Mm, okay. Now, on the line after line 2, can you create a new line?
Okay.
Oh, above that?
Okay.
No, no. After line, so s equals 1. And yes, there. And can you write s equals 2?
S equal to.
Okay. Before we run this, what do you think will happen?
I think it's will print three. Maybe three.
Okay. Let's run it. Let's see.
What?
Ah,
Oh, conflict name. So I have to train it. It can be assigned twice. I think so.
exactly. Yeah,
Oh, okay. Yes. So,
exactly. So different programming languages will have different answers here. In this programming language, you cannot declare a variable with the same name.
okay.
Why? If you think about it, let's say we are mathematicians, we say S is 1, S is 2. Doesn't make sense, right? We already said S is 1, why are we saying S is 2?
Okay.
Um, but there is another reason, and we'll explore this. There is a way to actually change the value,
Okay.
but we'll cover that in the future. But for now, just know that once you declare it, it's declared. Like once you say it, you have said it, it's there forever. You cannot change it.
Okay.
Okay, can we change S plus 1 to S plus T?
T
Yeah.
in generally.
Yeah, yeah, let's run it. Yeah. Okay, so we can add two variables together, right? No
Oh,
surprises there.
okay.
And can we on line 4, can we change it to S equals T?
S equal T.
Yeah, on line 4. Oh. Uh can we delete line 4?
Oh,
And then let's on a new line, can we write S?
S.
Yes.
Oh,
Okay. So S equals T. We have a variable on the right-hand side, and that's okay, right?
yes.
When it sees S equals T, when it sees T, it will see 1. So it will become S equals 1.
Okay.
So S becomes 1. Then S is 1. Yes?
Yes.
Okay, very good. So far we explored a little tiny bit of algebra. bit of variable substitution. Now we'll
Mm.
move on to a different idea of algebra, and that's functions.
Oh,
Functions. What is a function?
I think just is something that we just have to put the input inside and it will give us output.
Excellent. Inputs to outputs. Very good. Okay, let's delete everything and let's write fun.
Fun
Yep, space.
space
F, opening parentheses, X, closing parentheses, colon, new line, X plus 1.
S plus one
Oh, X. Yep, and new line, END.
EMD. Oh,
Okay, notice how it's all highlighted, so the language knows you are defining a function.
okay.
All right, let's run it. Let's see what happens.
Oh, yes, again.
Okay, very good. Now, so notice nothing happens here because we've only defined the function. We didn't actually use it.
Okay,
So a function has three parts. First, it has a name. This function name is f. Okay.
okay,
The second part is inputs. This function takes in one thing and it's called x.
okay.
Okay. Another in programming, another name for inputs is parameters. The parameter of the
Yeah,
function is x.
okay,
The third part of the function is its body. So x plus 1 is the body. Okay.
okay.
And so the X is the input, the body is what becomes the output. The body gets processed, computed, and becomes the output, right?
Mm,
So
right.
name, input, output, or name, parameters, body.
Okay,
Okay. All right. Let's create a new line. So in mathematical speak, we say we apply a function, or in programming, we say we call a function. So let's call this function. First, we refer it to it by its name. So let's write f,
F.
opening parentheses, and then any number.
Okay.
All right, let's run it.
Oh, okay.
Okay, very nice.
Okay.
Okay, let's notice how there are two windows. There's the left window which we have been typing in, but there's also a window on the right where we've been getting our answers.
Oh,
Can
okay.
we go on, can we stay on the window on the right? I'll lecture you to write F opening parentheses, but not there, on the right hand side. Yes,
F.
and any number. A different number. Let's try a different number. Great. Oh, don't click around, hit enter. Hit enter.
Oh,
Yes, okay, get a new number. Okay, so it looks like on the right-hand side, we can write one line of code, hit enter, and it immediately gives us the answer, right?
right.
Okay, very nice. Okay, so notice how, even though we didn't change our program, we didn't modify our program, it's the same, we got a new number, right?
Right.
So that's the power of functions. They can give us new things, but we don't have to change the function.
Okay.
Notice how when we pass in 99, x becomes 99. When we pass in 88, x becomes 88, right?
Right.
So there's a notion of variable substitution happening here.
Oh,
X can take on many values depending on what we pass in.
okay.
Yes, okay. So a little bit of explaining. The left window we call the definitions. This is our program. We write in
Okay.
our program and this is what we run. The right window, some people call it the console. The name is actually the REPL, REPL.
Okay.
It stands for read, R for read. It reads what you write. E for evaluate. Evaluate meaning simplify. It takes what you write and it computes the answer. So f of 88 is 89. it evaluates f of 88 to 89.
Okay.
P for print. Once it has an answer, it prints it out. L for loop. Loop as in it allows you to do this again and again and again. So
Okay.
REPL, REPL. Read, evaluate, print, loop. So
Loop.
you don't need to know this,
Okay.
but I'm telling you just so when I say REPL, I mean the window on the right.
Okay.
So notice how we are able to say f of 88. So whatever definitions we define in the definitions window, we can use it in our REPL.
Okay.
Of course, we can do many things in our REPL. For example, we can add two numbers in our REPL. Could you do that real quick? So you can't modify it anymore. Once you write something and hit enter, it's carved in stone. You can't change it, so you have to make a new line.
Okay.
Yes. Very good. So yeah, we can do anything here. Not all languages have this. Um, this language has it. This is
Mm.
because this language is designed for beginners, and what's important for beginners is fast feedback, and this gives you fast feedback. You can learn
Okay.
very quickly with this. So I encourage you in your own time to play around with this. Just try things out.
Okay.
Okay, so to summarize what we have done so far, we have covered numbers, arithmetic, variables,
Yeah.
and function definitions. Basic arithmetic and algebra, essentially, but all on a computer.
Okay.
Okay, now I would like us to do something a little bit different. I'd like you to delete everything now.
Okay.
I'd like you to write 5.
Fine.
I'd like you to run it. Now let me ask you, what does 5 mean?
Just fine. I think.
5 means 5. Okay.
Okay.
Now let me change the question. What does 5 degrees Celsius mean?
5 degrees Celsius. Yeah, the temperature.
Temperature, how cold, how hot it is, right?
Okay.
How about 5 kilograms? What does that mean?
And just how heavy is.
Okay, how heavy something is, how light something is, right? So even though they're all 5, depending of whether or not I say 5 degrees Celsius and 5 kilograms, it means something a little bit different, right?
Yes.
So there are two worlds. There's the world of information and there's the world of data. Information is ideas and facts about the real world. So 5 degrees Celsius is information.
Okay.
But data is what the computer sees, what the computer understands. I say
Okay.
5 degrees Celsius, but the computer will see 5. Like right in front of us in that program, it sees 5 and it sees data only. Okay?
Okay. That's
So it sounds philosophical, but it's a very practical idea. I claim our job as programmers is to facilitate the interaction between information as programs. We
okay.
turn information into data, perform operations on data, and turn data back into information.
Okay.
So we say that we encode information into data. And
Okay.
another way of saying this is we represent information as data. Okay.
Later. Okay.
Okay.
And
So to reframe everything we have done so far, we have encoded information as numbers. Now,
hmm.
let me ask you, can we encode all information as numbers?
I think yes. Okay. To some extent.
Why do you say yes?
Because I think that even ChatGPT or some AI that can say our language, but yet language is just one and zero, binary one. So I think
Hmm,
yes.
it's a good answer. Like they say, right, computers are just zeros and ones.
Yeah.
Everything we do is, at least on computers, are zeros and ones, yet we can do amazing things.
Mm.
Next question. Do we want to represent all information as numbers?
I think yes, because it can computerize it. and automated work to some extent. Yeah. I think it.
Okay. But let's say you and I, we are talking right now, but I'm
Okay.
not talking to you in numbers,
Oh,
right? I'm not
right.
talking to you in numbers. I'm not saying 0, 1, 1, 1, 0, 0, beep, boop, beep, boop, right?
Yes.
I'm using words, I'm using language.
Okay. Understand.
See what I'm saying?
Yes, I understand.
Why, why don't we talk to each other in numbers?
Because by talking like this, we can deliver more information and we don't have to decrypt it into our understanding. Yeah.
Okay, so it's efficiency, right? If
Yes.
I say 0, 1, 1, 1, 0, 0, 0, 1, 1, 1, it's very hard to understand me. It'll take a long time,
Yes.
but words are more efficient. Okay,
Okay.
it's more understandable to a human being, right?
Yes. We are human beings.
You know how they say that a universe is just a bunch of particles?
Yes, I know it. Okay.
Like in front of me, there's a table. I see a table, but in the eyes of the universe, it sees particles.
Oh,
But what's
okay.
useful to me is that I see it as a table,
Okay.
right?
Okay.
So, okay, so it's a very simple idea. We encode information, and numbers aren't enough. We wish to have more data representations, more ways to encode information. Okay.
Okay.
So I'm going to introduce a new data representation. I'd like you to delete that five.
Right?
Yes, let's delete that five. And I would like you to write double quotes, hello, comma, space, world.
Hello, mama, space.
Oh, the space as in a space bar,
World.
world. Closing
Okay.
double quotes. Very good. Let's run it.
Oh, okay.
Hello, world. Now, notice how we didn't get back a number. We got back something different.
Mm,
We call this a string, like a string of characters. Okay.
okay.
This
Yes.
hello world example is it's a bit of a rite of passage. In the
Okay.
1970s, there was a programming book that used this example. And ever since that day, every book, every video, every lecture, all use this example. So this is a very important milestone in your life.
Oh, okay.
Hello world. Yes. Okay. So we have strings. Now, so this is an additional way of encoding information. We are now using words to encode information.
Okay.
Okay. Just now we saw numbers and we can perform arithmetic on numbers. Now, can we perform arithmetic on strings? Can we add two strings together?
I think yes. Let me try.
Let's try. There's only one way to find out.
Okay.
Very good. So we can, right?
Yes.
Can we change the plus to a minus?
Minus.
Yeah.
Oh, left side, right side plus. Oh, to be given two number.
Expects to be given two numbers. The minus only works on numbers, not strings.
Oh, okay.
So what arithmetic means for strings is very different from arithmetic with numbers.
Hmm.
Okay, so now we have crossed the point where we are past using a calculator. We're no longer using a calculator. We're doing something much more advanced.
Okay.
Okay. Okay. Let's delete everything.
Let me see.
I'd like you to write double quotes. Five.
One.
Okay, let's run it.
Okay.
5. Okay. Now let's do new line and let's do number 5. No quotes, just 5. Let's run it. Okay. So I have a question for you.
Mm.
Now that we have strings, and strings are a series of characters, and to
Yes.
write a number, we need to write a series of characters.
Okay.
Why do we need numbers? Why not use strings for everything?
Um, because it different format, I think so.
Different format. Okay. And what about different format matters?
I think like yes, like we have just string five plus another five, or another string five is 55. But if this five plus another five is 10. Yeah.
Okay. Moreover, we can subtract two numbers, but we can't subtract two strings, right?
Oh, correct.
Right. So you're correct, and I'm adding on to what you said. And so the operations between numbers and strings are fundamentally different.
Okay.
So while the same piece of information can be represented with multiple data types, there are strengths and weaknesses to each.
Okay.
Okay. And as a programmer, part of our job is to determine what's the most appropriate data type, data representation to use to encode a piece of information.
Okay.
Yeah. Okay, so to summarize, we have covered numbers and strings, and we have learned how to perform arithmetic on them. I'm now going to introduce our third data type. Oh, by the way, when I say data type, I mean a classification of data. So a number is a data type. A string is a data type. Okay.
Okay.
Okay, so now there's a new data type that is used to encode decisions. So we can
And
encode numbers, we can encode words, now we can encode decisions.
oh,
Decision is very important. It can be said that life is a series of decisions where
okay.
a decision is fundamentally yes or no,
Oh,
on or off, right or wrong,
okay.
true or false. This idea of duality.
Okay.
So these are called booleans, named after George Boole, who is a mathematician who studied these as mathematical objects. In
Mm.
programming, these are called true and false. Could you delete everything and write true? That's true.
GRUE. Okay.
Yeah, lowercase. Yeah, perfect. Let's run it. So
Oh,
true, we get back true. So true is a value in this language.
okay.
All right. Let's change the true to false. Let's run it. Very good. True and false. Okay, so now we get false and another value. So we have true and false. Very nice. So these two are booleans, and these are the only values for booleans. For numbers and strings, you can write an infinite number of them. You have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 for numbers. For strings, you can say hello, world, bye, goodbye. So many words. But for booleans, you only have true and false. Nothing
Okay.
else. All right. I would like you to write false and true. That's false and true.
Oh,
Okay, let's run it. Get back false.
oh,
We started out with two booleans, and now we ended up with one boolean. Can we
oh.
change the N to OR? That's OR. True.
Two.
False or true is true. Okay. The
Oh,
same way we can add numbers and strings, we can add booleans. So we can perform arithmetic on booleans.
oh.
Okay? It was okay, so that's it for booleans. Could you share your screen again?
Oh, okay. Now, so, okay. You see it.
It's loading.
Okay.
Okay, great. Um, so we have covered three data types, numbers, strings, and booleans, and we showed that we can do arithmetic on each one of them.
Mm-hmm.
Arithmetic means something different for each data type.
Okay.
Okay, now I have a surprise. I'm going to paste a piece of code into Zoom chat.
Okay.
Oh yeah, there's no XOR in. So Python only has AND, OR, and NOT. Some
Oh,
languages will have XOR.
okay.
All right, yeah. All right, let me paste something into Zoom chat. I don't know why it's not pasting. Okay. Uh, I've just pasted something into Zoom chat. Could you copy it and paste it? But don't run it yet.
Okay.
Perfect. Now, what do you think is going to happen once we run it?
I think it will draw a circle.
We'll draw a circle. Okay, let's run it. Let's see.
Oh, oh,
Ah, so circle is a function. It takes in
oh,
properties of a circle.
oh.
Could you change around the arguments?
Change angle.
Yeah, let's change that around.
Oh,
Ah, so the number is size. The bigger the number, the
oh.
bigger the size of the circle.
So what about solid?
Good question. We
What, yeah.
okay, let's leave that for now. I'll show you later.
Okay.
No, 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 I'll show you later. Let's keep it solid. How about red? What would be other words for red? What could we do?
Yes, properly color. Yeah.
Color, right? Yeah, let's try it.
Oh. Hmm.
Very good. Okay. Give me 1 second. I'm gonna show you something again.
Okay.
So just now you asked, okay, what about solid? So when you're learning a language, right? Sometimes you have a dictionary with you. If you see a word you don't understand, you can look up the dictionary, right?
Okay.
But when you're learning a language, you don't read the dictionary from A to Z. You use it whenever you find something you don't understand, right?
PNG.
No, no, no. So I've pasted something in Zoom chat. Could you click on it?
Okay.
Yes.
Oh,
So this is the dictionary for the
this.
circle.
Oh,
So we don't call it dictionary. We call it documentation in programming. We say this is the documentation for images.
oh, okay.
So to your question, okay, if it's not solid, what can we do? This is the answer for you.
Oh, it outline.
Outline. So that's the second option, right?
Yes.
Okay. And here we can see many more images. There are more than just circles. For example,
Elite.
ellipse. Yep.
Oh,
We see line. We see so many.
yes.
Okay, can we look at the circle again? Yeah, can you scroll
Also.
up a little bit more? Yeah, 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 scroll up. Okay, so here we see the top, the circle, radius, mode, and color. You see that? So this is like the function, right? But without the body.
Oh, yes.
Okay, so what we is sometimes called the signature or the function header. So first it has a name. So we see circle, that's the name. Second, we see the parameters or the inputs, radius, mode, and color. And we see the
Okay.
outputs, the image. But we
Yes.
do not see the body.
Oh,
Yeah. So we call this the signature. Or
signature.
yeah, what the function takes in and what does it provide and what is its name.
Hmm.
Okay. So the signature of a function is like data. It's for the computer to understand. Okay. But the description below that constructs a circle with the given radius, mode, and color. That's information. You see
Okay.
that? So
Yes.
there is, again, back to the idea of information and data. There's a description for the human, and there's a description for the computer. What do we have to write so that the computer can understand? Okay?
Okay.
All right, we are running out of time, so I think it's time to start wrapping up.
Oh,
The way I like to end my sessions is I like to ask my students, what is one thing you learned today that stuck with you?
I think it's about a circle because I have never seen a code that can draw a circle before.
That's excellent. Awesome. Yeah, not all languages have this. And
Oh,
images are a data type in this language.
oh,
Um, because a data type, it doesn't have to be fundamentally philosophical. A data type can just be useful. This language is designed for beginners, and beginners are sometimes children, and the images are fun. So this
okay,
language has images as a data type. So to
okay,
summarize, we have covered numbers, strings, and booleans. These are like cash. If you're lost in a city and you have cash, you can probably get what you need. If you have
okay,
information you need to encode, you can probably use one. You will probably need to use one or more of number strings and booleans. We covered images. Images can be used to draw things so that people can look at pretty pictures. Yeah, that's it. Um, I'm glad you're able to join me today. I'm very glad to be able to help you on your journey on learning programming. Do you have any questions?
no.
Okay, in that case, I hope to see you again. All right.
Okay. Yeah,
Bye bye.
see ya. Bye. Hmm.